Hello everyone, my name is Diksha and I am from the Bodhi Academy. I have started with the 12th standard chemistry and today I am going to take the continuation part of alcohols, phenols and ethers chapter. So let us start with the alcohols, phenols, ethers continuation. That is, in last part we have seen regarding reaction involving cleavage of OH bonds. Okay, so today we will continue with reactions involving cleavage of CO bond in alcohols. Okay, so the first reaction here is reaction of alcohols with hydrogen halides. Okay, so alcohol, when you react with hydrogen halide, okay, so what you get is this reaction we have already seen our previous chapter, that is haloalkanes and haloarenes. So we will get alkyl halide plus water. So this alkyl group combines with the halogen here and hydrogen combines with the OH group and we get the respective products. Okay, so if we take example here, we will take CH3OH plus HCl. So what product this is going to give us? This will give us CH3Cl plus H2O. So we will get methyl chloride from methanol. Okay, so this is about the reaction of with hydrogen halide. Next we will see reaction with phosphorus trihalides. Okay, so reaction when you react an alcohol with phosphorus trihalide, that is PX3. Okay, so the product that we will get here is 3RX plus H3PO3. Okay, so 3R and 3X, they are going to combine with each other and they will give you 3RX, and the P here phosphorus and this 3O and 3H, they will combine and they will give this acid that is called as phosphorus acid. Okay, so we will get an alkyl halide with phosphorus acid. So these two reactions come under preparation of alkyl halides from the previous chapter. Okay, and so this was the second reaction in which we have seen the cleavage of CO bond. So you can see that here, if I take example, I will take 3CH3OH plus Br3 will give us 3CH3Br plus H3PO3. So here which bond is breaking? This carbon and oxygen. This bond is breaking and we are getting CH3Br. So bromine is going to take place of this oxygen, that is OH group, and we will get the new product, that is methyl bromide. Okay, so these are the two reactions from the we are already familiar with. Next is dehydration. Now in dehydration also we can see that the CO bond is breaking. So here if you take alcohol and if you react it in the presence of acid and heat, if you heat it, what you will get? There will be dehydration that is going to take place. Dehydration means what? A loss of water molecule. So we will have H2O that will be lost here. So we will get the product carbon with 2 hydrogens on either sides. Okay, for both the carbons we will get 2 hydrogens. We are left with 2 hydrogens and there is a loss of water molecule. So to complete the tetravalency, here we have to write the double bond. So here the formation of double bond will take place. So we will have, from alcohol we will have alkene. So if I take example here, we will write C2H5OH. Okay, ethanol, when it is treated with H2SO4. Now H2SO4 is going to give us this H plus ion and 443 Kelvin temperature is used. So what we will get? We will get CH2CH2. That is what? This is ethene plus a loss of water molecule. Okay, so from ethanol we are going to get ethene molecule. Okay, so this is about the dehydration of alcohols. Okay, then we have oxidation of alcohols. Now in while studying the preparation of alcohols, what we had studied that when you reduce the alcohol, we get respective aldehyde or ketone. Okay, so reduction is opposite of oxidation. So if you reduce the alcohol and if you are getting the if you are reducing the respective compounds and you are getting the alcohol from that, then if you oxidize alcohol or if you carry out the oxidation of alcohols, you will get the same compound again. Okay, so let us I will give one example to you. Okay, so what we had studied in the preparation of alcohol. So if you want to prepare an alcohol, what we do, we take RCHO and we use some reducing agent. Suppose let us take this LiAlH4, lithium aluminium hydride. So this aldehyde is going to give us alcohol by reduction. Okay, so aldehyde will give us RCH2OH and aldehyde will give us primary alcohol basically. So this was about the reduction. Now oxidation is exactly opposite to this. So there will be opposite reaction taking place. That means if you oxidize the aldehyde, if you oxidize the alcohol, okay, if you oxidize the second primary alcohol in the presence of this anhydrous chromic acid, okay, so what we are going to get, we will get RCHO, that is an aldehyde. So from alcohol we will get an aldehyde. So this is primary alcohol, so we will get aldehyde. Okay, second is about the alcohol in which we have double bonds present. Okay, so that time we will use this another reagent, that is pyridinium chlorochromate. Okay, so here when we use this, what product we are going to get, we will get CH3 CH double bond CH then CHO. Everything is going to remain the same, only there will be difference here and here. Okay, so here instead of OH we will get CHO group. Okay, so here we will get aldehyde, here also aldehyde only. Okay, so example of the first one I will write CH3 CH2OH, that is ethanol in presence of CrO3, that is chromic oxide. We will get CH3 CHO. Okay, so here we will get from ethanol we will get ethanol. Okay, ethanol to ethanol. Okay, yeah, so here also we will get an aldehyde, that is in presence of pyridinium chlorochromate. Second, if you take a secondary alcohol meaning what? When the OH group is attached to the carbon, which is further attached to two more alkyl groups or carbon. So here we will get, if you see, here I will get R, C, R dash, and here this H and this H, they will leave. So you will have a double bond here and you will get R, C double bond O, R. So from secondary alcohol, 2-degree alcohol, we will get ketone. Okay, from secondary alcohol we will get ketone. The next is about, okay, this reaction comes under oxidation reactions only, but here the reagent is different. So here you take copper, okay, copper fillings. So when I take primary alcohol in presence of copper at 573 Kelvin temperature, I will get RCHO, that is an aldehyde. If I take secondary alcohol in same conditions, under same conditions, I am going to get ketone. So this is the product. And if I take tertiary alcohol, now here I will not get any functional group, here I will get a double bond. Okay, so here I will get CH3, C, CH2 and CH3. So this is the product that we are going to get when you take tertiary alcohol. Okay. The next we will see about the reactions of phenols. Now these are the very common reactions that we have studied in last chapter also, electrophilic substitution reaction. First we have studied the basic about that, and then we have we have seen the how to attach the different groups which we are attaching in the electrophilic substitution reaction. So in nitration, basically we are adding a nitro group. So for that we have to take the reagent, that is dilute nitric acid. Okay, so when you treat phenol with dilute nitric acid, we are going to get two products. Meaning basically we are going to get mixture of two products. Okay, so I will get these two products, that is one is ortho and one is para. So we have already studied why do we get ortho and para products at the when you carry out the electrophilic substitution. Okay, so because there is electron density more on ortho and para position, that's why we will get only para and ortho product and not the penta product. Okay, now here we get the mixture of ortho and para. Okay, so but the major is para and the minor is ortho. Now why the major group is para, that we will see now. See, in para product we have OH at first position and NO2 as fourth position, and here we have OH at first and NO2 as second position. So what happens here, when you get the mixture of these products, and if you want to separate, suppose if you want to separate para product from here, then you have to carry out a steam distillation. Okay, now in lower classes we have already studied about the distillation method. So here you have to carry out a steam distillation. So when you carry out the steam distillation, what happens, one product or one of the product from here, it will be it will escape. Okay, so one will be volatile and one will be non-volatile. So one will escape and other will remain. So the para product here, it forms intermolecular bonding with other groups, and this from intramolecular bondings. Okay, now we will see how it forms intermolecular and intramolecular bonding. Here we have NO2, right? So I can write this as NO. Okay, I can write NO2 like this, and here I have OH. So this H and this O from NO2 will form hydrogen bonding. Okay, so this is intramolecular hydrogen bonding, which is not that strong. And this OH and NO2, okay, they can't form, they will not be able to form a bond with each other. So what they will do, they will form intermolecular bonding, that will be between other atoms and this. Okay, so here intermolecular bonding will be there, and that is very strong. So because of this intermolecular bonding, this product is not volatile and this product is volatile. So that's why we can separate easily by using steam distillation method. Okay, now when we use concentrated nitric acid, that time we will get a product in which we will have 3 nitro groups. So we will have OH, 2 nitro groups will be at ortho position and 1 will be at para position. So the name of this will be 2,4,6 trinitrophenol. Okay, and the common name of this is picric acid. Okay, which is very common. So here what you have to understand, when you take dilute acid you will get 2 products, ortho and para, and when you take concentrated we will get a product in which there are 3 nitro groups attached to the phenol ring. Okay, next is halogenation. Now halogenation means what? In last chapter also we have studied. Halogenation means when you carry out the halogenation in presence of certain reagents, we will get halogens attached to that compound. So here we have phenol. If you carry out halogenation, that is we are adding bromine, this bromine gas, okay, in carbon disulfide, that is a solvent, at 273 Kelvin temperature, we will get OH with bromine at ortho position and with OH with bromine in para position. Okay, so these are the products that we will get here when you carry out the halogenation. Then when we add 3 bromine molecule, okay, 3 bromine molecules of bromine gas, that time what we will get here? Phenol. Okay, so that time we will get 3 bromine attached. Same like nitro groups, we will get bromine groups attached. Okay, and the name of this product will be 2,4,6 tribromo phenol. Okay, so this is the name of the product that we get here. Next is Kolbe's reaction. Kolbe's reaction is basically about the preparation of salicylic acid. So here we first prepare sodium phenoxide ion, that is we take phenol plus sodium hydroxide to get this sodium phenoxide ion. When it is further treated with carbon dioxide and H+, that is acid, we will get OH and COOH. So this is called as, the IUPAC name will be orthohydroxybenzoic acid and common name is salicylic acid. Okay, so here this reaction is very important and it is very common. It is asked, every year it is asked in the exam. So yeah, so this is a preparation of salicylic acid. So you need to understand how it is prepared and what are the reagents that are being used here. Okay, it's not that difficult. Next is this is also a very important reaction, that is Riemann-Tiemann reaction, in which we will study how to convert phenol. Okay, now phenol when treated with this CHCl3, that is chloroform, with aqueous NaOH, we will get CHCl2 group attached to the benzene ring, one of the carbon, and we will get a phenoxide ion. When it is further treated, we will get an ion with aldehyde group, that is CHO group. Okay, and when it is treated further with acid, we will get OH and CHO, and this is called as benzaldehyde. Okay, so that is acid, salicylic acid. This is salicylic, not benzaldehyde. Okay, so the name of this will be salicylic. Okay, so these two reactions are very important, in which we are preparing salicylic acid and salicylic. Salicylic acid is Kolbe's reaction, salicylic is Riemann-Tiemann reaction. Okay, then next is reaction with zinc dust. Reaction with zinc dust. Now this is a very simple reaction and also a very important reaction, wherein we are converting phenol to benzene. Okay, so when the conversion comes, like convert phenol to benzene, then you have to use this reaction. When phenol is treated with zinc dust, we get benzene plus zinc oxide. Okay, so this is about conversion of phenol to benzene. And the last one is oxidation reaction. Okay, where we use chromate. So here we use phenol plus sulfuric acid and chromic acid, and here we get diketone. Okay, here we get a diketone, that is we get 2 ketone groups attached to the benzene ring, and this is called as benzoquinone. Okay, so this is the product when we do oxidation of phenol. Okay, so one more oxygen group adds and we will get benzoquinone. Okay, so this is about the this reactions. We have seen electrophilic substitution reactions and the cleavage of CO bond in alcohols. Okay, now we are left only with ethers. So ether part we will do in the next part. Okay, and all the preparations, physical properties and chemical reaction, all we are going to do in the same part. Okay, so yeah, this is enough. Okay, so thank you for watching this video, and ethers part we will do next time. Okay.